Okay, so what I'm going to be teaching you guys about today is how to calculate the moments about different sections of a beam, and the moments will be the forces about points. So here I've drawn out a beam to be 8 meters long, and it has a uniform total weight of 10 kilonewtons throughout this whole beam. So over here we can see there's a pin location holding the beam and another pin location holding the beam where this is on rollers. So because this is a pin location here and a pin location here, when calculating the moments at these pin locations, it's always going to be 0. So we can say that the moment about A and the moment about E is equal to 0 at these two locations. So what I'm going to do is I divided the beam up to A, B, C, D, and E locations. That's where we're going to be calculating the moments about each of these points. So the first thing you do is after we found the moment at A to be 0, we're going to go ahead and calculate the moment at B. When we calculate the moment at B, what we're going to do is cut the beam at the point we're calculating. So we're going to cut it right here at beam B, and this is where I've drawn right down here. We have a uniform force of 80 kilonewtons where we have the distance multiplied by the weight. So over here we have 40 and over here we have 40. So now that we cut it here at B, we can see we have 40 upwards acting here, and over here we have a distance of, from the point B, we have a distance of 1 meter since the total distance from A to B is 2 meters, and we're going to multiply that by 20 because we have 20, 40, 60, 80. We have four sections of this beam and it needs to total 80 kilonewtons. So this section right here will be 20. So we have 20 multiplied by the distance away from B. Now this distance right here is 1 meter. So we're going to do 20 times 1. So we have 40 multiplied by the distance from B is 2. And then this is going to be acting clockwise, pointing upwards. So we're going to keep it positive. But when we're doing this force right here acting downwards, which is the weight of the beam, we're going to do the opposite direction. Counterclockwise is going to spin the beam. So this would be 20, which is the force, multiplied by 1 meter away from the point B. It's going to give us 80 minus 20. We're going to have a total moment here of 60 kilonewtons. Okay, so this is our moment here at B. Now we've found the force here and we found the force at A, we're going to go ahead and find the force at C. So we're going to go find the moment at C to be cutting a beam at the point C. So we're going to have 40 go over to C, B, and it's going to be 2 meters, 2 meters. So now we know that we're going to put the force starting at A again. We're going to say this is 40 multiplied the distance away, which is 4. And then we have to find the next force acting on this whole beam. Now, again, the force on the beam happens right at the middle. So at the middle here, it's going to be 2 meters away from point C where we're calculating. So now we have 40, so again in the opposite direction, 40 multiplied by the distance away from C, which is 2 meters. So now, if we calculate this out, we have 16, and we have 80. So this is going to be a moment of 80 at point C, kilonewtons. We're going to repeat these steps for D and E, and this is how you calculate all the forces about the moments in this beam.